Totally fine. Yep.
Matt, do you do the recording, or can I turn that on, or is it already on?
It's on.
Okay. No, never mind. I don't care whether you consent or not, Sam.
No, I think that's fine. That's
Matt's in Texas. Everything's legal there.
no, that's no big deal. Let me share my screen. And also you can actually point me. I mean, in this way. I mean, if I'm taking a really good look at the launch file, I should know what's changing my, the URDF file and where it is being changed. So I'll just get to know that too.
Yeah. So I don't have a secret process here. I'm wondering, say, for example, if we just take this as an example.
Sure.
If I go back to this, tell you what I'm going to do. I'm just going to create a new sheet here and just take some notes. I think the simple question for me is, what measurements would I have to take in order to calculate those numbers?
Okay, so let's start with let's say, for example, for our lawn tractor model, right? We would need a base link. Then we would need a base footprint. And then let's say we have two sensors, which is the GPS and camera. So this is our basic kinematic, the model that actually just with these four links, let's say that these are our four links, and then each of this link, it just basically fits to a tractor, which what we're talking about. So let's say, for example, your base link, you wanted to place it right at the crosses of the all the axis, like a wheel axis. So that would be like right at the center of the rear axle. That would be your base link position.
Yeah, and so again, what
Yep.
we had previously captured is well, I guess we didn't load the base link. We just we measured, what's the center line of the rear axle,
Right.
and then I think what you're saying is the
This
base link
yeah.
is measuring the distance from the ground to the center of the axle.
Correct.
Well, I'm not sure what base link is.
So let me put it this way. So like, let's say your tractor now, let's actually take it in terms of X, Y, and Z. So let's say your front of the tractor is like axis along is the x-axis. So that's your tractor's like a lengthwise. And then your z-axis would be going up and your y-axis would be on your left of the tractor. So that's how we wanted to situate, our XYZ. Okay, now we have the base link. Consider that just as a point at this point, just the point. And that base link point, let's say, for example, it's right at the center of the rear axle. So let's say now that rear axle is about 25 centimeter high. So we're saying that 0.25 from the ground, that's the axle, the rear axle center, that defines that point. So I would say, okay, well, in that case, I wanted to say, okay, if I am taking my 0, 0 at that point, so my base link would be, let's say, x0, y0, and z 0.25. And let's consider that's just as a point at this point. All right, so that's one point. The second point is, let's say you wanted to have your base footprint, right? So your base footprint is basically your, the top-down projection of your base link. So that will be 0, 0, 0. Let's say, for example, we start from there. And that will be exactly 0, 0, 0. All right, and then now we're saying that, okay, where would be my GPS. So your GPS is front, like let's say top of the hood would be according to your dimension, we will start measuring, let's say from the ground, so from, let's say now let's make the base link as a reference, that point as a reference, and say my GPS would be from the base link about, let's say, half a meter high, which is 50 centimeter high. It will be in front, X direction front, because that's X is going in the direction, of the tractor's length, right? So my X would be, let's say, my half a meter, or maybe even a meter. I'm not sure at this point what would be the exact point, but just for the sake, let's take that about a meter in X direction. Y is exactly 0 because you want it to mount, right at the center front of the hood. Fine. So Y is 0, and your Z would be from your base link would be, let's say, about 50 centimeter high. So it's like half a meter again. So for GPS, my point would be, let's say, for example, of X direction 1, Y direction 0, and Z direction 0.5. And that assume that as just as a point. I mean, just don't think about the link at this point. And then your camera. So where is your camera is mounted? So it's right around like where your, probably the kind of a headlight level. That's your camera is mounted. And that would be from base link, I would say, let's go 1 meter in X direction. And then Y0 because you're mounting right at the center, let's say, for example. And your Z is like almost similar, like the same height as the base link height, which is like 25 centimeter. So now you got all these 4 points, right? Are you with me so far?
No, I'm a little lost.
Okay. Let me show you over here if I can share my screen.
Yeah, happy for you to do that. I mean, before you do that, though, I think what I'm trying to get to is, okay, so for the camera, what are the 3 measurements or 4 measurements or 2 measurements we need? And I think the answer is
XYZ.
How far off the ground is it?
Yeah, the base link, let's say, for example.
How far away is it from
base link?
Base link.
Yes.
Right? And with those 2 measurements, you could probably tell me X, Y, and Z what the calculation is for the camera.
Correct.
Right?
Yeah, because that would, assuming that, and then we are going to call that, this is just for your reference, your visualization purpose. And we're going to call that as a camera link.
How far off the ground is the GPS? And how far away is it from base link? With those 2 measurements on GPS, could you then calculate the X, Y, Z?
Yep. So let's say how far off the ground meaning we're base footprint. The how far off the base link's pretty much, self-explanatory. Like where is the base link, what we're placing the base link. And the distance from where we are mounting the GPS and where we're mounting the camera, we would know. I mean, it's easy.
And so if I just give you some sample data here as an example,
Yep.
I've got a GPS that's, I'm going to pick a number, 3 feet off the ground, and it is, 4 feet forward from the base link. And if I've got a camera that is 2 feet off the ground and 5 feet forward of the base link.
Sure.
I'm trying to figure out, so the GPS, as an example, if I go back to your, there's base link, there's chassis, there's GPS. Here's the origin statement
Yep.
for GPS. You know, and because base link is, you know, is the only piece of information you need on base link is how far it is off the ground.
Yeah, and then remember, when you define the link, the link's dimension under the geometry tag, like the origin, it's not the actual distance, you know, from the ground. When you defining this origin is basically, it's the way of telling you where the center of that link is. Meaning, in other words, what's the center of mass located for that link. And this dimension, what you're showing me, the origin, when you define it under the link, that's not the distance that you want, you know, from anything. That's just the link's own dimension with its own center of mass where it is located. So let's say, for example, let me simplify.
Well, let me give you the example. Here's a tractor, and the center of the rear axle is 24.8 inches off the ground.
Right. So let's say 24.8 inches off the ground, right? So that's where the base link position is. But when you define that link, you know, that link, when you define this origin, that origin is like kind of self-contained. It means that the link of the base link, you know, the let's say if you have the dimension already, if you have the size of the base link, let's say, for example, my base link is like a square, right? So if my base link is square, it means that when I define my base link, you know, the center of the square is where the center of the mass would be. So you would, when you define 0, 0, 0, like for your base, sorry, the link, base link dimension origin, it will be link's center point, that what the origin defines. It doesn't define how far off that from the ground or from any other point. What defines the distance between the ground and two other links, it's the joint. So your joint dimension is very important. And your joint dimension is actually makes your kinematic diagram complete. And then it will also, your joint dimension, actually, when you define the joint, that is the origin that would give you the distance from, let's say, from the ground or from the GPS, you know, or from your camera or from any other point. And then that joint dimension is actually where the TF frames are located. So it means that, let's say, for example, you remember when you actually look into the RVs, right? So when you visualize that, where you can see the XYZ arrow in terms of TF frames, and those reference frames are located right at the joint. And that's why you define joint, and joint has a different types. Fixed joint is where you don't have any movement between two links, right? The continuous joint is where it can rotate around one axis. You have to define. You got the revolute joint. You got, you know, the planar joint. You got prismatic joint. You know, and then that's where you start defining where your joint is located and how it behaves. What is it actually? So your link, in other words, has its own dimension in its own matter. It doesn't say anything. The dimension of the link, where you define with the origin, it's link itself. Don't think of that as an distance from anything. It's the joint that you want it to actually focus on. So let's say, for example, in this case, your base link would be 0, 0, 0, 0, 0, 0. Like, let's say, for example, it's just a square, or it's just like a rectangular link, for example. And you would define that base link as not 1, 0, 0, just 0, 0, 0, and RPY. Now, you have the base link, and then the similar way you can define the base footprint. And the link would be origin 0, 0, 0, RPY is also 0, 0, 0. Now the most important part. Now you're defining the joint. And that's where it actually, you can define that how far your base link from your base footprint link is. And that's when you define Okay, now I'm actually I'm actually defining a joint, my base link, and in between my base link, between my base footprint, you have to decide that what's your parent link. Your parent link is your base footprint, let's say, for example, and your child link is your base link. All right, so now you got two links and two arbitrary position at this is right now anywhere, but now you're locking it into your XYZ. So now you were saying your third dimension would be now you're defining the origin for the joint. And that's when you define, okay, my parent is my base footprint and my base footprint is right at the ground. So now my base link would be, I want it to be, let's say in this case, 25 centimeter high. So what you're going to defining is your x is 0, your y is 0, and your z is 0.25. That makes your base footprint locate right at the ground, which is 0, 0, 0. And let's call 0, 0, 0 as a ground, right? And then your base link would be 0.25 meter high at that point. And if you have any rotation, you have to define at that point in terms of r, p, y. So there you go. There you have actually just defined a link, which is in like relative to each other, and you exactly know that how high my joint is, and your joint is like exactly at the definition of 0.25. So x0, y0, z25. That's how your first link is defined. And now what you're going to do is you're going to base off the base link. So now let's say you have the GPS link, and GPS link has 0, 0, 0, like its dimension. Link is the visual part of that. You can either put like a link as a rectangle or whatever it is. I always put it like a small dot or like a small sphere, just to visualize, that, oh, link is there. You can always replace that with DAE file or STL file. You wanted to give it the visual representation later on, kind of a deal. But now you have the GPS point. Now you have established, the one link, which is the distance between your base footprint and the base link. Now you wanted to put the GPS. So your GPS, let's say, for example, it's like about, as you said, 1 meter, maybe, in the X direction, and probably 25 centimeter into the Z direction. It's a little bit higher, right? And right on the hood. And whatever your dimension is, that's really easy. So now you define that my GPS link is there. Now you're defining the joint, and what's the GPS joint? Let's say, for example. So where is that GPS joint? When you define the joint, you're just gonna say my parent frame or parent link is my base link. My child link is my GPS link. And how it is connected, so where you define your X is 1 from parent, your Y is 0, and your Z is your height of where the GPS is mounted.
Sam?
Yes.
Can I ask you a question?
Sure.
If I told you that my rear axle, the center point of my rear axle is 2.1 feet off the ground,
Yep.
would you be able to complete that origin statement for the base link?
Sure. It's 0, 0, 0.
So instead of 0.05, it would be that.
Yes, 0, 0, 0. I would just put right there, assuming that your link's center of mass is represented with 0, 0, 0 at this point. Now it can be offset if you wanted to represent it with the the CAD file, but that's a different story. But right now, let's keep it simple. Let's say 0, 0, 0.
And again, I'm assume it is a lawn tractor or a tractor similar to this photograph, if you can see that.
Absolutely.
Okay, and then so let's just talk about GPS. If my origin for my base link is this, and my GPS is 3 feet off the ground and 4 feet forward from the base link, what would my origin statement be?
Okay, Matt, sorry, Matt, I didn't catch that before, but Matt's saying that base link is 000.
I'm sorry, Matt, you're on mute, Matt, if you're trying to talk.
Yeah, no, that's what Sam just said. So the origin, just like a map origin, this has kind of a robot origin, and that robot origin is the center of the back axle, 000. So everything is measured from that point, in relation to that point.
That's why I asked the questions the way I did. Is
Yep.
If you knew that the GPS was 3 feet off the ground and it was 4 feet forward from the base link, what would that origin statement be?
Still 000. That's what I'm saying. For the definition of the link, it's 000. For the joint, it would be different.
Well, I mean, when you say the joint, let me bring back up your URDF file. So
Yeah,
here's the URDF file. What line are you referring to?
So you see that link, like let's say, for example, if you see the link name on top, it says GPS, link name as camera, right?
I just got to scroll up a little bit more. He's in the joint definition. So right below the robot, you'll see the link tag.
Give me a line number.
Line number 3.
Let's take a look at the line number 3, 4, 5, and then 13 and 14.
It defines your positions. It doesn't tell you the location. It just kind of names them.
And this is the way of defining the virtual links. So let's say, for example, if you just see the name, it means that it is defined as a virtual link. It means that it has no geometry. And you usually wanted to define just one virtual link, which is like your parent link, basically your root link. So it means that in this case, we have to add the dimension to it. Like for the base link, we don't want to define that as a virtual link, which has nothing, in it. So you wanted to have the geometry, like let's say, for example, you wanted to add the visual elements to it. You can have only maybe one, like a virtual link, which has no geometry. That should be fine. And that's what I'm talking about. If I can show you my file, let's just go through that. I think I'll just make your the understanding really clear once I show you that the file. Let me show you. Okay, so this is what I've been playing with. So let's say, for example, I'm not gonna show the launch file at this point. All right, so this is like, let's say, for example, as I said, we need the base link, we need the base footprint, let's say, for example. And then you have the GPS link and you have the camera link. So now so this is I defined as a virtual link. It means that I have just the link name. I do not have any geometry attached. But in most cases, you will have the geometry attached. For example, what I have changed in this case is base link. And I have changed the base link and I'm attaching the file, which is the mesh, the CAD file. And I'm putting my origin over here as 0.55 just to fit, this lone tractor, the CAD data. And what I was trying to tell you is this 0.55, it's not any distance from anywhere. This is where the 000 of the CAD data is located. That's what I'm specifying over here. Remember again, so this is not the distance from anything, like not from the ground. This is the CAD data itself in the center of the CAD data where my 000 is located for the tractor, like a CAD data. That's what it is right now. That's what it's showing.
Sam, on this origin of that, that's kind of where you hang the image around BaseLink. So sometimes I make a big difference if I want to see. You can just change that 0.55 to 0.5. Okay. And what will happen is the image will be 5 meters in front of the origin or BaseLink. If you put the Z at 5, it'll be 5 meters above yours. So it's just where do you want to hang that image
Correct.
in relation to the base link, which is 0, 0, 0.
Correct. Correct. Yeah. So if you define your base link as 0, 0, 0, so and that's exactly true where you wanted to see or visualize your link, and this is the dimension for that, for your link only. But like let's say for example,
shows the image.
Correct. Just for the image. And then usually what people do is, let's say for example, right now the tractor CAD model, like your center is right at the center, like at the ground. That's what I see when I looked at into the Blender. Let's say for example, if I'll just launch the Blender and I'll show you that where I can see that just right at the center of it. Okay. Is there a way that I can share all my screen?
I'm not sure.
Okay, so over here, if I open this file, and this is your, let's say your CAD, your whole model, and this is the center of it. This is where you see the 0, 0, 0. This is where the center of the whole CAD data is, right? So when you actually transfer from one file to the other, like a one CAD format to the other, you will have this shown everywhere.
I'm assuming when you say the center, you're referring to the circle with the blue and red line coming out of it.
Correct.
So it is when whoever created the CAD file, the 0, 0, 0 on the XYZ for the CAD file.
Exactly. So now, go ahead.
Well, I'm just curious, when the 0.55 that you've got back in the URDF file.
Yes.
It's 0.55 from what?
I got it from over here. So let's say, for example, so in this case, you can see that my x-axis is pointing towards my right?
I'm not sure where your cursor is, Sam.
Oh, over here. Can you see my cursor or no?
Move it around in a circle. I'm not seeing your cursor.
Ooh, okay.
Are you seeing the cursor?
Setting. Okay, so you see the red arrow?
Yes.
Okay, so that is your x-axis. That's pointing towards your x. You can see it over here too, like in the left side, a left corner, left down corner.
Sam, up at the top, I think that there are annotation devices at the top if you view options or of your Zoom window.
Annotate, okay. And okay, I just see that now. Oh yeah, okay. So see over here. Now can you see that?
I can, yes. I can see the red circle you drew. I still can't see your cursor. But...
Exactly. So this is my x direction. This is my y direction. And you can see it from over here too. Sorry, this is my z direction, the other one, the blue one. As you can see it over here.
What I'm curious about is something is 0.55 something from your 0, 0, 0 position. What is 0.55 from that point?
I'll show you what is that, just let me, so let's say for example, over here, I'm just going to put that into the quad view. Let's say for example, if I put into the quad view, and now you can see in probably from every angle that your X, Y, where is the X, Y, and Z, right? So let's say for example, this is my, right at the center, you can see into the all of, the four, the images. So now, if you can see, can you see my cursor now?
No, unfortunately not.
Okay, I'll just draw it actually. That'll be easier. Okay.
I love that view, by the way. I'm getting a Blender demo at the same time.
Let me see. Okay, draw. All right, I'm just going to use that. Okay. As you can see over here.
Okay, I saw that.
That's your X, that's your X, and that's your X, right? Like in all the views. And then this is your Y, and this is your Y. And obviously the blue is blue is your Z, obviously, and that's your Z. So let's say, for example, whoever draw this cat, it has the 000 right over here. So what we did, like let's say now your base link, you wanted to place it right at the center over here, which is
I'm not sure where you're at, Sam.
or can you see? Let me erase the original. That's challenging, eh? So I'll just erase everything else, and then I'll show that where we wanted to put the. Hang on, I just have to get rid of that last one. Okay, done. Everything's gone. All right. Now I wanted to actually pick a diamond and then say, this is where we wanted to, you can see the diamonds. This is where exactly center the rear axle. You wanted to put your base link.
Right.
Okay, now your link has a visual, which you're defining via link element. So you don't leave it empty. If you leave it empty, it will assume that it has nothing, no geometry associated, and it will not render anything, and it will just come empty in RVs, and just the virtual link. You don't want to do that. You just wanted to actually give it a visual. In most cases, it is really important. So when you give it a visual, you can use either a primitive objects like a square, sphere, or rectangle, whatever it is, or it will give you that you can also use the mesh file, which is your CAD file. And in this case, we wanted to use the CAD file for the link. Now, base link, that's supposed to represent the whole vehicle, let's say, for example. In this case, we have to deal with what we have over here. Like, let's say in this case, we have this CAD, and it's exactly located at your X, Y, and Z 00s right in the center, as you can see. And now, when I define my link, I wanted to actually put my base link right at the point, onto this tractor where it exactly sits at the rear axle in the center, right? Okay, so that's our challenge. Now, as you can see that our robot in ROS always faces the front, and front is always X. In this case, you can see that your tractor is actually situated 180 degrees in the other direction. Your front of the tractor is. So first thing first, your link will have the rotation element, which is 3.14, which is 100% 180 degree rotation on your Z axis, because you have to rotate it and you have to make sure that your front of the tractor lines with the X axis. Okay, so that is in your link element, and that's your Z rotation. So your RPY would be 0, 0, 3.14. Now you have 3.14 because you have to actually specify that in a radian, and then that's 180 degrees, which is 2 pi. Sorry, just a pi, right? It's a pi. Yeah, so it's pi 3.15. So that so that defines your.
Pull up your URDF file.
Okay, let me show you my URDF, and it is there. It's interesting, right?
Well, what I'm lost on is what, if you were pointing, which line item of your URDF are you talking about?
This is what I'm talking about.
You're still talking about line 10.
Yep, from 8 to 15. If you can see my screen over here.
Yeah, I get it. That's the whole,
The link definition.
But the actual calculation that needs to be done is for statement number 10, right?
Correct. Exactly. That's what we're trying to get at. It's exactly the line number 10 right now. That's what we're at.
Before you move on to the RPY,
yeah,
I'm still a little bit lost on the 0.55. How was the 0.55 calculated?
So I took the RPY first. Now we are moving to the XYZ.
Oh, okay. In RPY, then you're saying that third element is the orientation of the CAD model to the base link.
Correct. And then you wanted to see your tractor right in the front, and that should be your X direction as per REP 103. So we wanted to follow that. So it means that we're going to rotate the whole tractor, make sure that it's in line, it's front of the tractors in the direction of the X. So that's what it's just going to be in the X direction if you rotate that all the way 180 degrees. Now let's talk about the origin. So I'm
Before you move off of the RPI, or could you go back to your CAD model?
Sure.
I mean, I confess I'm more familiar with Fusion 360 than Blender.
Oh, I just used it last week for almost for the first time.
Blender or Fusion 360?
Blender.
Wow. Is this orientation, I mean, certainly Z up, I'm very familiar with Z being up and X and Y being left and right, as it looking at, say, the front ortho, your top right.
Right.
I'm a little, why?
Okay,
You're having to tell Ross that what I consider to be a normal orientation is 180 degrees off.
You see that the red arrow is your x-axis, and that's pointing towards the rear of the tractor.
Instead of the front.
Right.
Exactly.
So the orientation is incorrect. I mean, maybe you could draw it or change that thing around, and then you wouldn't have to rotate the image. But you can, inside of ROS, you can rotate that image wherever you want it.
Okay.
Yep. So that's the reason that we are actually rotating in the Z axis. So it means that you will just go rotate 180 degrees to make it in line so that your front of the tractor is also in the direction of X.
And the RP, back to your URDF, that argument once in radians, once it in radians, that's why you put it in pi.
Exactly. Yes. This is 3.15. This is just a dollar construct. It's easy way to represent, the 3.14. You don't have to type it. Just you say pi, and pi it's already defined. So you don't have to just say 3.14. Yeah, I think these are the easy constructs, and then you should use it as often as necessary. So you don't have to worry about 3.14 and then rest of the digits,
And so again, just to be redundant and consistent, RPY arguments it's expecting Z to be up, down, it's expecting Y to be left, right, and it's expecting X to point front to back.
Correct. So, and in that case, in order to do that, now my orientation of the tractor is correct if I rotate it along the Z-axis. So imagine that your Z-axis and you were like twisting it 180 degrees. Mm-hmm. It's pretty easy, and that's why you just have that your Rubik cube. So if I have that, and then if I have let's say for example, if I'm rotating it 180 degrees, my the the Z-axis. So assuming that it's rotating this way, 180 degrees. So now here is I rotated on my Z-axis 180 degrees. So now orientation is completely 180 degrees out. Okay, so now that takes care of the rotation. But we're still not at the origin. So we're going to take care of the XYZ part now. So let me show you again. I'll stop sharing this and I'll share the another screen.
So there's a difference between the base link origin and then this image origin, and that's what you have to measure.
Yeah, so, and that is what I'm measuring when I said 0.55, I actually was coming towards this point. And this point's far out in X direction, 0.57.
Sorry, Sam, I'm not seeing your cursor.
Oh.
You zoomed in on the front ortho, but I'm not seeing what you're, okay, I see you. On the right-hand side, you've circled location.
You see that? And this is my 3D cursor. So I place it over here just to see that where is my X on the center of the wheel. And that gives me 0.57. Now I know that I'm far out on Y, but I don't care because I just really wanted to see how far I am on my X. Your Z is over
And just
here.
sorry, Sam, just to confirm, you the data in the location table for X, Y, and Z is representative of the rear axle, the center of the rear axle in the front ortho view?
Correct. I mean, almost, because I actually picked the point right on the screen. And that is actually right at the center of the, the wheel, like the rear wheel. And then that's where I just wanted to see that how far that is off from my 0, 0, 0. My CAD 0, 0, 0 is right at the center. And how far off my center of the wheel, the rear wheel. And that shows me that you are far out like about 0.55 meter in this case. Let's say, for example, assuming that the whole unit is in meter. So I'm far out, like on my X is 0.55, and my Z is, I can see 0.33. So I mean, just for the simplicity's sake, I'm just going to take, okay, my X is 0.55, or you can even take X is 0.5, and your Y is 0.35, or you can say your Y is 0.3. I mean, just a simple number, But you should be exact in many cases, but this is just for the modeling, and just to see that if you can put that.
I guess if you wanted to be more precise, wouldn't you have 3 numbers in your URDF? You would have 0.57 minus 0.41 and 0.33?
No, because I see my point is, I've not taken my point right here. I mean, can you see my third circle I just drew?
Right.
Okay, so I have not taken there. What I have taken is I have taken somewhere around here just to take the reference X. So I have taken somewhere over here, and that's why Y shows me a little offset on that, into that negative, the Y direction. But if I take it like right here, let me erase, and let's take the another point. Because remember, your Y is right in the center, so you don't have to worry about the Y, because you wanted to put your Y line crosses across, and your tractor is similar on both the sides. Your Y is right in the center, so you would not touch Y. You just have to, if you have to locate, your center rear X, the axle at the right height, you just have to change the X and Z, not the Y. Are you getting my point?
Well, let me test my understanding. So if I were writing an instruction on how to update line 8 for the XYZ parameter, would it be correct to say, find the imaginary point that's in the center of the rear axle?
Yep.
To the original XYZ point when the CAD model was created.
Correct. However, let me tell you this. What I was trying to do is I was trying to change the origin, and I wanted to put that in the right center of the rear axle, facing the front of the tractor in in X direction. So you don't have to do it like in your launch file. If you place the center 000 right at where you want in your CAD file, that makes life much more easier.
Say that last sentence again. If you wanted to make your life easier, you would do what?
You have to put this X, let me show you again.
Sam was just saying, if you put the origin of this tractor image at the imaginary point of the center of the rear axle, then all of your dimensions on line 8 would be zeros.
Yeah, that makes sense.
Yeah. So if you, let's say, for example, my square, like a rectangle box, a square box right now, what you can see I just draw. If I have to make everything right, I will put my X, Y, and Z origin, transform from that point to right at the rear of the axle, and then make sure that I also align the x-axis to the front. So I would do that the translation and the rotation right into the CAD data, and then bring it at the 000. And then you don't have to change. Let's say, for example, if you do that, then you don't have to change Um,
Yeah, I think the instruction should be get a good CAD modeler and move your model around so line 10 is 0, 0, 0 all the way across.
Exactly. Now you're getting it. So this is your representation, of your link, and your link could be your whole model or just that part. It could be like, let's say, if you're doing the humanoid, then it just could be just the torso, or it could be the right hand or the left hand, or it could be the right leg or the left leg, or something like that. And that's exactly, it's the representation. And if your CAD is right, you can directly put that link in 000. Again, it's very important, when you do it into the gazebo, because gazebo is actually really finicky, and then it really, if you're actually simulating more often physics, it really see that where your link is placed, because it sees that that's where the whole mass is located, like the whole body weight kind of deal. So it's very important when you do the calculate the inertia, and then all the moments around it. So that's where it comes very handy, if you know exactly where it should be. But for the other modeling, I think it should be fine. I mean, as long as you just define the geometry in visual element. This is over here. That's your visual element.
Okay. Can we talk about line 24?
Absolutely. So let's say line 24 now, and this is the GPS link. So now, if for GPS link, I'm assuming that you may have the GPS model. If you don't have the GPS model, then let's say you're like me and you're putting the GPS as a sphere, right? And with the radius of 0.05 meter, which is like about 5 centimeter. Your origin would be, in this case, 000, because remember, you're putting your visual as just the radius. Just a sphere. And the center of the sphere is 000. This is what is 000 means.
So line 24 is somehow explaining the orientation to line 26. It's not explaining the orientation to the base link.
Right. This is just the link definition. You have to remember that. There's no distance over here that you're specifying from one point to the other. This is link itself. Everything you're defining over here, it's the link itself, as if it's not connected to anything. Let's say your GPS link is in your XYZ world, anywhere. You don't know right now. How you represent that is, you wanted to represent that as a sphere. And where is the center of the sphere is your center of, the mass located, let's say, for that sphere. That's what you're actually defining right now, XYZ 000. This is your CAD right now. Because your actual CAD file is not available for the GPS, you're visualizing your GPS as a sphere. You can visualize that as a box, or you can visualize that as a cylinder or anything else. Doesn't matter. Your origin would be 000.
Am I going to explain later where the GPS physically is in relationship to the base link?
Absolutely. And where you define that is right here. So this is your GPS joint. And now you're defining your GPS is located somewhere, but you don't want it to locate it somewhere. You want it to locate it right on your vehicle, right? And your vehicle has a reference point. What is that reference point? It's the base link. Because now you define the base link, where the base link is. You exactly know that where the base link is. So you're now defining, okay, my GPS joint would be the distance from, like my parent link would be base link. My child link would be GPS point, which is like just a sphere at this point, like just to visualize. And what's the distance, from my base link? And the origin over here, that's the most important dimension. This dimension is actually your distance, physical distance in meters from your child link to your parent link. You can define it over here. And
these are meters, right?
Was that?
Row 70, those numbers are in meters. So the physical location of the GPS joint is 1.25 meters along the x-axis from base link
Yes.
Right on the center line, i.e. the Y, and it's a 0.5 meter above.
Absolutely. You're reading it right. Perfect. And there's no orientation rotation, but if you have any, then you can define in terms of RPY. But I'm saying that my GPS is in line. My GPS axis like straight ahead, in the direction in the front of the tractor, the same way.
Okay.
And this is, I just wanted to tell you again, like just to visualize for the more understanding purpose. This is your GPS frame. And how do you visualize that you're getting the GPS data in this frame? So you wanted to visualize that, okay, well, why this is important, why I have to do this, right? So when your GPS reads the data, your GPS will read the data in terms of X, Y, like your latitude, your longitude, and your, the MSL, your mean sea level height, whatever it is, right? So you are getting that X latitude, longitude, and the height data in your GPS frame, exactly in your GPS frame. And then let's say, for example, you get that into the GPS frame. But now you are thinking, I want that into my base link, the frame. How would I get that data, my GPS data, into my base link frame? Well, forget about the base link. I wanted to get it into my ODOM, the frame. How would I get that into my ODOM frame? Or maybe how would I get it into my map frame? Or something similar. That's when, the link definitions and the references comes into the picture. Because let's say if your GPS data, your long, if you're getting it into your GPS reference frame, you can easily calculate now what your base link into your base link frame, just because it has a physical dimension. You would know that you have to actually how much into the X that you have to take it out, how much into the Y that you have to take it out, and how much from Z you have to take it out. So now you confidently say that, oh, my base link frame has this GPS data now. And it can be converted, fortunately, to any of the frames. You don't have to actually do any math.
Can we scroll up in your URDF, say back to the row 20 and work our way down?
Sure. Okay, so.
So then you explain the sphere, you explain 24 and 26.
Okay.
And then how about 37?
Sure. So let's say 37.
With the camera, you didn't have a 3D model, so you sort of created it using ROS, created a sphere and said,
exactly. Just to visualize that where my camera is, and my camera is sphere. Contrary to the notion, I should have put the box maybe. But hey, that's fine. I mean, I know that my camera is a sphere.
The color, I see numbers in row 29 and 40. That's just giving it a color, right?
Correct. Yeah. It's very, very, very simple. So in this color is really RGBA. So it means that I wanted to visualize that as mostly red. My G and B, they're like green and blue, like they're like 0, 0. And then A is your transparency. So I wanted to actually see that half transparent. I don't want it to have a solid red, the block there. I just wanted to see it more transparent so that I can also see the frame. If I'm putting any joint, my TF frame, it's more kind of visual, so I know that where it is. Right?
Okay, the next numbers I see, row 49. There's an XYZ there, mass.
Oh, is this over here? 49.
49?
Okay, yeah. So that's xacro. That's actually I wanted to take that up into our next meeting. But I can explain. The xacro is really like a good macro sort of program, in order to do the most complex kind of URDF. And it actually shines where you have multiple joints. Like, let's say if you're designing a vehicle which has like more left and right, so you don't want it to define all the links. my right wheel link, my left wheel link, then my front wheel link, or maybe rear wheel link, and then your rear right, then your rear left, then your middle right, middle left. All of these things, right? Sort of things that you don't want to write like all the links like this, like, okay, yeah, this is my 1, this is my 2. Xacro actually makes this compact. So it means that you just write it once, and then you have some sort of prefixes, the postfixes, and then you have some other parameters that you can write, and this is how you define the macro. And then you can actually call the macro. Calling macro is really easy, and that's how we can define the link. Now I can show you the example that I'm working on. And this is a little complex URDF.
I'm not sure. Sam, boy, it all sounds interesting, but I have no idea about the xacro at the moment. So
and just trust me, if once I go through it, it'll be very easy.
Okay.
So like in a URDF, you can't do loops. It's not like a programming language, it's just a text file. And so xacro allows you to do loops and call, it's like a function call or object oriented a little bit more. So it adds that functionality instead of just a flat text file.
And this is what the URDF would or should look like. I mean, this is like simple, still a little complex, but it has a lot of xacro. So as you can see over here, let's see the xacro, that's how I'm defining. So let's say I'm defining the wheel, and this is my link wheel. And then I have the parameter that I define prefix and suffixes and reflect, And this is like one time I'm defining wheel link. Once I define that, I can create as many wheels as I want in terms of the link. I don't have to worry.
Got it.
How I'm defining my wheels. I just have to call this macro. Like, for example, if I'm calling it over here, you just call it, and then you just create the link.
Where are you where's a call statement? What does a call statement look like?
So 143 is my call. You can see that? So my xacro, I'm calling, like, let's say wheel, and I'm defining my prefix would be middle, my suffix would be right, and my reflect would be, I'm just one, I'm not using that. And then this is defining the link, and the one line and my link is defined, and I can directly go to the joint statement, and I can define it.
And then if you go back to your macro definition for a second.
Sure. This is my definition of macro. This is over here. I mean, let me show you in the full screen, be more easier to read. So this is my xacro.
And so it takes those 3 parameters, and then it's effectively a function call.
Exactly. It's very easy once you know it, and then you would love it just because it actually saves a lot of time. Because in this case, like, let's say I have 6 wheels, right? So I just wanted to say, okay, calling the macro, boom, one line, and then, defining the joint, and I'm done. You can also define
it's more like an include with parameters.
Exactly. Something similar,
Okay.
Very, very powerful, actually. And then that's why, remember, most of the time you see the .urdf.xacro, and I was confused between that, why you wanted to use the .urdf and .xacro. But this is like sort of convention. If your URDF has a xacro file, remember, the xacro is parsed to the URDF, and URDF can be read by your RVs and also your gazebo, right? And then your RVs reads it differently, your gazebo reads it differently. I mean, internally they pass this to their own format, and then they read it. But the xacro, basically, it's like the macro program, right? So it has to convert back to the URDF. So you're simply using the URDF. You don't have to do URDF.xacro. But URDF.xacro means that, okay, well, when you convert that and when you check the links, you just see that into the URDF. I mean, there's just no other point. But when you use actual xacro, you have to actually include the namespace so that it can actually, this is like a schema, the format that you can read and just similar to the XML.
Mm-hmm.
But this is like xacro macro within the namespace, XML namespace, which is probably RS thing. My understanding. Okay, I'm not an expert, but my understanding.
Since you're in Ann Arbor, I'll make a university joke. So Professor Sam, will this be on the exam?
There's no exam as long as you learn.
Back to the URDF or the lawn director.
Okay. Let me share my screen.
We're in row 70 or something like that.
Sure. Let me open that. I think that's the file that I was working on. Yeah. 70, right? Okay.
I think we're about there.
Okay. Okay. So this is my GPS joint that we already defined. You know that this is actual.
Sorry, 63.
63? Just right here? Okay. Yeah. So this is my base footprint. And the way I have defined right now is I'm making my parent link as the base footprint. But I think what Matt is saying that my base link should be the parent link of the base footprint. So vice versa, either way. Right now I'm defining my base footprint to my base link has 0.25 meter distance in Z direction.
So would that mean something is sitting above your rear axle? Right?
Now, well, something sitting below. So my base link is about quarter meter high.
I think so. The parent link is where you're starting from, and then
Correct.
the child link is where you're going to. So in this case, the z-axis is up because you're starting. The parent is the base footprint, and the base link is up. If you reverse and make the parent the base link and the base footprint the child, z would be negative.
Negative 25, 0.25. Yeah. Correct.
Same thing.
Absolutely.
I don't. What is physically? If you go back to your 3D model,
sure.
I don't. Whether it's up or down, what is offset by 0.75 on the z-axis or 0.25 on the z-axis from your the center of your axle? I don't understand what imaginary point you're trying to define.
Okay, so exactly this point that we're trying to define, and I'm trying. Probably I'll try and explain, and Matt's also here, so I think we may be able to explain. So I'm taking again. So this is exactly the point. As you can see that where the wheels are touching the ground, and that base footprint is the point where we're trying to define where the wheels are touching the ground. Exactly that point that we're trying to define. Now you would say why that is important. For many reasons. The first thing first is if you wanted to avoid any obstacle, like when you're actually driving around.
Well, hold on, let me clarify. Because that green line, it appears the wheels are just slightly below that green line.
Well, it's just a visual, might be actually looking like that, but exactly that, let's say that's the ground level. That's where the wheels are it's like on top of that ground. But that's where you can see the green line, exactly that line. I mean, that's the ground is, let's say, for example. I mean, over here you see a little bit down, but let's say it's not the case. And it's exactly located on that point, which is the ground point.
The 0.25, is that representative of the wheels are below the imaginary line?
No, right at that point. So the 0.25, remember we put our base link over here. We put that base link over here. This is our base link. And now we are defining the base footprint link which is, we're saying that like about 0.25 meter down below,
Okay.
right,
Okay.
right on the ground.
So if I were writing an instruction, I would say get out your tape measure and measure the center of the axle to the ground.
I would say you just have to like take the the radius of the wheel, and then that's exactly where you would touch from the center of the axle. That would be exactly where you touch the ground. That's the point where you want to define that as a base footprint. Now, if you ask me that if it's important over here, I don't know, maybe not. Base footprint, just a link where it's just a direct, the ortho projection of your base link. In many cases, it's important. In many cases, I don't think that you may have to define it, or you have to define it, or something like that.
I think if I were being more precise in the instructions, it would be, what's the diameter of the wheel loaded, or the radius of the wheel actually.
Yeah, and that's where we're just defining that as a virtual link. That's where the link is. If we ever need to use that link as a footprint link,
Okay.
we can use it. But I think most of the driving around, and then references are coming from the base link. And
Got that.
You want to use that.
Back to the URDF.
Okay.
And so on 63, you're only really worried about the distance between the base link and the ground.
Exactly. Yeah.
On the z-axis, not too much worried about x and y.
Nope. Because
orientation.
That's exactly where my base link is, right down.
And
like projection.
We talked about GPS before.
Mm-hmm.
And so on camera, row 77, this, well, you want the XYZ discussion, or you want the RPY discussion?
you start. I'm fine. XYZ is fine.
Yeah, I think the XYZ is a little bit easier than that angular orientation.
Yeah.
So the 1.5 is at 1.5 meters in front of the physical base. Is it going to be base link?
Yep. So starting from base link, your child link is camera. That's how you're visualizing, like as a sphere. And then you want it to go from base link to the camera, and then that's 1.5 meter in X. Your Y is 0 and your Z is 0, because your base link is already about 0.25 meter high as per my current configuration.
And so your camera is, according to this, your camera is exactly level with the center of your axle.
Yes.
Okay. And let's talk about orientation. So you've got negative pi minus or divided by 2. So it's a 90-degree rotation.
Yeah. So negative 90, which is so our counterclockwise and then the clockwise. So this is like the RPY is just basically, if you take a look at, this is the right-hand rule. So whatever the right-hand rule says, you go like around the x-axis. I believe that if my Z is up,
Sam, I'm going to stop you. Remember, we're going to go find a smart 3D modeler, and he's going to adjust our model to have. Is this linked to the fact that the model is offset?
Well, this is where you wanted to have your optical frame, like this is not the part of the link thing. This is like if you wanted to place your optical frame in what they call is I think like a front. Your X would be your right, your Y would be down, and your Z would be in front of you. So
this doesn't have anything to do with the fact that the 3D model is a little bit offset.
Nope.
Okay.
No, because that's the link definition. This is the frame definition, like the joint, like where you're getting the data. So this is the frame where you get the data from the camera, and it's pretty easy to actually visualize. Let's say if you're actually taking a picture, right, and you take a picture, your depth perception is your Z, for example, right? When you take a picture,
Right.
your X is your in your right direction. Your Y, remember, because your image start from 0, 0 on your left top corner. So your image starts from 0, 0. That's your first pixel, 0, 0 in your 2D image, right? So that's your Y. It's going, your Y is going down, like from that 0, 0. Your X is going from, the left to right. And your Z is actually coming out of the picture. That's your depth perception, right?
I'll
So
take your word for it.
that's how we put the link in. You don't have to, but then this is like the optical frame, kind of deal.
Yeah,
If I always put the camera facing forward on the center line, would I always have this negative pi divided by 2 and negative pi divided by 2 for the X and Z?
If you're actually getting the data, how I'm reading it, like the camera or the video stream, whatever it is. Yep. Yes. I mean, if you like convert
that's the
that.
definition of the camera frame.
I mean, if you would, I mean, you're not doing anything unusual with the camera, right? You've stuck it out on the front of the tractor 1.5 meters away from the rear axle and perpendicular, no, parallel with the rear axle.
Right.
I mean, so this negative 90 degrees and negative 90 degrees is always, it's just how cameras are structured, right? And the way Ross handles it.
Yes. I mean, as long as I understand that, that's what they call the optical frame. You can read about that in, I think, 103. That's how you get the data into that frame, I mean, and it's actual, all the cameras works like that, right? I mean, your whole image, it starts from 0, 0. So in your left, and then your TV is also, your screen or your monitors is everything, it starts from 0, 0, and your end is the diagonally opposite, which is your, the screen total pixel, 0, 0, and 200, 200.
Okay.
It will be 0, Y down positive, right? And then Y up negative. So this is what it is.
Wow. See, I had dreams of, listening to you guys, updating the spreadsheet, and we'd be done, but this is more complex than I had thought it was going to be. But hey, Sam, you did a fantastic job. Thank you for taking me through that. The 3D model is really important, right? That's one of the key takeaways.
It is. It's, and then if you have that origin at the right place, your link definition and the visual is really right on the spot.
Do you think, Matt, Christian, who helped us with the angle sensor gear, would know Blender well enough to know how to, or STL files to reorient it to match the base link?
I don't know. We can ask him. If he uses SolidWorks, you can export right out of SolidWorks. It'll export a URDF file. But if you're concerned about just rotating the tractor 180 degrees,
just to make it simpler.
Yep. Yeah, I don't know. I don't know how to do that in Blender. There may be a way to switch that around and switch the origin point.
I was trying to do exactly the same thing, and then that's how I wanted to use that, the Blender. But right now, it has so many different parts of the whole assembly that it's just not allowing me to do it, and I'm not really know Blender well that I would do something with it, So it's just, for me, it's okay, I wanted to do it, but the question is how, you know.
Where
And,
did the STL file come from?
From the Olin Research Lab.
So from a modeling standpoint, what would be helpful for us, and I'm just reiterating what's in my head here, reorienting the STL file so the base link is 000, getting a model of a GPS antenna, and what was the other thing you drew as a sphere? Was it the camera?
just the camera, and then that's just a visual.
Yeah, I mean, not that I have any secret sauce about how to get those three things done, but
If you get, let's say for example, if you get the CAT file for the GPS and CAT data for camera, we can place it as if they're like placed right on the tractor hood on top of that, or just in front. You know, we can actually model a mount and then put the camera on top of that too. That's no big deal. That can be done.
yeah, I mean, I just Googled reorienting the XYZ in Fusion 360. Where would I get the STL file, Matt? Where is it stored?
I uploaded the Kaleido file up to the GitHub, so that the source file is up there.
You can find it in the simulation folder under simulation under masses. There is a DAE file, and I think you wanted to use that because DAE file is just more elaborate. You know, has textures, colors that artists can show. STL is more of a bland solid. You know, the one color file. You can use both. It doesn't matter.
Yeah, I've imported a 3DS file into Fusion 360 before. That's pretty straightforward. You think which is better, Sam?
DAE. .dae file is the Collada file. It's the also the neutral format and for the 3D.
But I'm not seeing that in the lawn tractor model.
It should be there. .dae file.
I see three: a .3ds, a .max, and a .tga.
That's interesting. Hang on.
So there's a link to the meshes in the chat file.
Trying to get there. Oh, okay. I see a tire, a chassis, a front tire, a tractor, no tractor.
Yeah.
So 3 DAE files: back tire, chassis, and front tire.
So remember, only 4 formats that we really require: the ones the STL, the ones OBJ, the ones like .dae, which is the Collada, and the ones STEP, step file, and all the neutral file formats. And I think we need to know all of these, but mostly we will use DAE and STL in most cases. All the other formats are also like being used, which is OBJ is also, you can be able to use it in your 3D printing needs and stuff. And your STEP file, it's just mostly automotive stuff, where it's a neutral format, so I think we need to know all of those formats. Actually getting from one to the other, to the other, to the other can do
it. Matt, you want me to reach out to Christian and ask him if he'll give us some time?
Sure. It's nice to have models, then you can see how things come together and the way it works.
Yeah, I'm just looking at, there's a website called GrabCat, see if it has any GPS antennas as an example.
Yeah. My job of explaining the URDF to you guys is complete.
Yeah, good job, Sam.
Yeah, really. Way to go, line by line. torturously, 11 o'clock at night.
And that's what I was thinking, that I would rather actually pick on the fundamentals rather than just doing a one-off file for you, because I think now you can do any file.
Oh yeah, absolutely.
You
Turn,
I'm
turn,
not seriously. You can do
turn.
any file now. I mean, you trust me on that.
Yeah, we're ready to be turned loose. You know, just give me, a life-threatening uh, moving device with spinning blades. You know, that's what I want. Yeah. Okay.
No, well, it's just a part of learning. I mean, I try to understand more in a fundamental way. So, like, at least I can apply that to anywhere. And I think the kinematic diagram URDF is, I think it's at the center, of your model. So I'm glad
Yeah,
that
you're really reinforcing just how important that is. That along with the whole 3D design process as well. So
yes,
visualization. Um,
it helps. It helps a lot.
the more you dig, the deeper it gets, Matt. It just goes and goes and goes.
You'll never get bored, Al. You'll never get bored.
R2 Pilot was never this complex.
But it's the capability of RS is like just it has no end to it. Like you imagine can do anything in most cases. It's complex. I mean, nobody promises the rose garden, right?
Yeah, all with all that power comes complexity. So anyway, well, Sam, huge help. Thank you very much for walking us through that and being patient with certainly with me. I will, Matt, if you save this and put it someplace, I'll try to go back through it and spend time on the Excel spreadsheet, because I do think that would still be, there is some, hey, measure this and translate it. I don't, again, I'm going to think about the 3D model and reaching out to Christian to see if he can help us with that, because getting that to be reoriented, I think, would just make the task easier. But,
Simple. Just
It does, but if you don't have that, then don't sweat it. Like you probably should be able to get it with the link origin. You can place and like play with the RPY and a little bit of XYZ, and I'm sure that you will get it. Because how many combinations are you gonna try? You got only XYZ and RPY.
yeah, I think what I'm going to try to do in that regard, Sam, is get the model into Fusion 360 and play with it and see if I can replicate your measurements.
Sure.
And if I could do that, then personally, I'll be more comfortable with how to explain it, and then we can go from there.
Sure. If your Fusion 360 can do the DAE import, just and let me know that how it looks in Fusion 360.
Okay, will do. Kudos on learning Blender. That it felt overwhelming to me, so that's why I went with Fusion 360.
There was just a few screens that I learned. Honestly, I don't know Blender very well, but I just, like I said, whatever I wanted to use it, this is what it is. I just pull it in, and then I was just trying to see that if I can actually get some measurement out of it so that I can fit the model.
Cool. Matt, you've been awful quiet. Anything else?
it's great. No, that's neat. That's really neat. It's a good tutorial. I'll upload this to the tutorial playlist and then post the link in the lawn tractor so we can reference.
Well, I haven't bored you guys with a long talk, because when I start speaking, I just speak.
That was great, Sam. Cool.
Like that professor in a 500 level class is rattles on like I've written 16 books and you neophytes should understand all this. No, you did fantastic, Sam. Thank you for that.
Thank you.
Okay, guys, have a great day tomorrow. Get some rest.
Good night, guys.
See you, man.
See you then.